In this problem, we're going to find the domain of the function g, defined by g of t equal to the quantity 4t plus 1 divided by the square root of the quantity 5 minus t. And again, as we look at finding the domain of a function algebraically, we're looking for two things. We're looking for division by 0, and we're looking for the square root of a negative number. Any input values that would cause either of those to happen cannot be part of our domain. So as we look at this one, we have both a square root and an expression in our denominator. So what we'll see here is we have this square root of 5 minus t in our denominator. So we know because of the square root that 5 minus t must be greater than or equal to 0. And because that expression is in the denominator, we also know that 5 minus t cannot be equal to 0. Now this is what we call a compound inequality. If we look at combining both of these though, simplified, so 5 minus t has to be greater than or equal to 0, and 5 minus t cannot be 0. The simplest way to write that is simply that 5 minus t is strictly greater than 0. What that'll leave us with then is that 5 is greater than t, and if we rewrite that equivalently using t, we'll have t has to be less than 5. So as we look at writing this domain, the domain of our function g will then be the set of t such that t is strictly less than 5. And if we want to write that as an interval, we're going to have all numbers that are strictly less than 5. So we'll have negative infinity up to 5, and we'll use an open bracket on 5 since we're not including that number 5 in our domain.